What's going on, guys? KIM-1 here. So the last video I've been testing cc65 compiler with a KIM-1 target build, and this KIM-1 target build has been provided by Dave Plummer, the retired operating system engineer from Microsoft from 90s. And I had a success with running Hello World, but I didn't manage to run the prime numbers. But when I had a precise look at the makefile, it turned out that actually the prime numbers are designed for the KIM-1 with a 60K of RAM expansion, which means that the code starts not at 200th hexadecimal, but at 2000th hexadecimal. And the reason why it didn't work in my emulator is simply because my emulator didn't have that memory expansion, believe it or not. So if you have a look at the RAM, it only has this around 5K from like up to the riot chips basically, but nothing else really. So in this video, what we're gonna be doing, we're gonna be expanding my KIM-1 emulator so that it would be having the memory from 2000th hexadecimal, and well, I'm not sure if whether it would be exactly 60K or how much, but well, anyway, without further ado, let's get started. So first thing I want to know, so where the ROM is starting, and it doesn't tell me here. So maybe if I just search for read function, yeah, CPU read. Okay, so if address is greater than 1800, yeah, then this is the KIM ROM, and greater than 1700, okay, less than, okay, so is greater than, so here, let's call it 60K RAM expansion. So this is gonna be from 2000s to, I don't even know how to properly calculate that. It's a shame for me, but just hold on a sec. Yes, something like the following. So if we take the address FFF, so just need to make sure we're in hex. So FFFF, which is the highest possible address for the 652 CPU to work with, minus 2000. So this is going to be ZFFF, which is in decimal. It's almost like 60K. So I think that should be somewhere around what we're interested at. So let's make it greater than FFFA. So from to FFFA. Is this really? So how much would be? Well, if it just exceeds a little bit, it's not a problem. It still will be going here if the address. Okay, so I think we can probably just make it back to hex DFFF, or even +1 E0. So I'd make this size. Yeah, just make. It's not going to be used entirely, but or just to be 100% precise, we need to say FFFA minus 2000. So this is the size. So here, if address is greater or equals than thousandths, then we do our logic, and write memory, xiangqi expansion, and here goes the logic. And I also need to define the rate solve. Okay. Not sure if I do exactly the precise byte to byte thing, but generally this should be fairly enough. So let's create a variable RAM expanded, for instance, to new uint a array, size of this. Yeah, this should be it. And now dot read so I need the one that reads from the RAM. So the offset, yeah, I should just, before I completely messed up. So this is gonna be RAM expanded, and the offset is like this. We can simply return here. Yes, and for write, so I really hope I didn't mess up anything. I really hope. And for write, RAM expanded, and return. Well, I don't know, but yeah, let's have a look. So I need a local copy. Just need a local copy. Here it is. And to make sure the updates are there, need to update the cache. So here in now work. Yeah, cache is disabled. So I don't know, but from now on, if I go to 2000s and try to, nope, go into 2000s and go into data mode, Yes. Okay, so it seems like it's reading and writing really. Okay, going back to addressing mode. 2000s. Yes! It seems like it does read and write. Say like I just managed to write the values there to the emulator. So I think that our expansion should be working from now on. And make sure, well, not sure if I make sure, or if I don't. But anyway, I think now we can try already, or we can already try to compile again this thing, the prime numbers for the target KIM-60K expansion. This big beast. All right, this huge beast. There should be, here it is, save. So I want to make it again. Yeah, so the original size, just slightly more than 5K, and this should be starting at 2000s because we have this 6K target here. Okay, so this kind of makes sense. So go into test, paste. Let's make sure no extra new lines. Save. So far so good, and convert to DCB format. So here is our updated DCB format, and now I grab it. And this is the moment of truth. I'm really wondering, is this actually going to be working? So I paste this in and assemble, and 0x 2000s. This might not work because the assembler, the uploader at assembler. Oh no, actually this would work, but this probably wouldn't, because let's have a look. Yeah, because I also need to deal deal with uploader. Okay, not so fast then. So it just doesn't upload. Well, it makes sense because the uploader only relies on the standard RAM. So I need to change the assembler's uploader as well. So how can I do that? So let's go to KIM-1 JS assembler. Yes. And wondering about the RAM. Clear memory before upload. Run button. I guess this run button is what in my case is upload. Just to make sure we're here. Oh, yeah, it's taking a little bit longer than I thought, but anyways, this might be really interesting to get it work eventually. Okay. Yes, so it's here. Okay. So clear KIM RAM or KIM memory before upload. So also I want to clear the expanded RAM as well. So RAM expands it, and RAM expands it to be cleared every time we upload as well. So if origin is less than, okay. So let's make it else if here, if origin is greater or equals than well, actually I'm not sure, why am I, so this actually should have been the hexadecimal value. Why did I ever, oh no, this was correct. No, it's actually, how did it even work? I'm not sure how to test that. But, okay, if I break something, I will fix it up later. Doesn't matter. So if origin is greater or equals than 2000s, so we're going from the origin okay, so hold on a second, I want to make sure that I didn't mess up anything, because maybe I just broke it already. So now it was like this. Okay, let's make it like this, because ultimately that should be the hexadecimal value. If I go like LDA symbol, so that's origin 0, upload, okay, we got it. Symbol origin to hundreds, okay, we got it. Yeah, it's probably couldn't upload the program bigger than, yeah. Okay, so hopefully makes sense. Origin greater than this, so we're starting from the origin and origin plus code size. So RAM expanded I is equal to memory get I. But this should be minus this offset. Yeah. So the moment of truth is about to come. Okay. So if I say when I assemble at 2000 and upload, and seems like here we go. So hopefully this should work. Okay, so in this case our prime numbers should be still on the cards. Assemble 2000 and what? Oh, I didn't upload. Okay, now I did. Okay, let's just make sure and have a look at the hex dump of yeah, the reason why hex dump is actually not printing this is because yeah, it just doesn't know about it. It doesn't know the RAM can be there, so I need to fix this as well as the disassembler, I believe. However, yeah, I need to alter that as well. But I believe that Oh my god, can you believe this? Prime numbers work. Calculating primes to use blah blah blah, located 656250 bytes for 1000 slots. Is this working now, or? Yeah, it was working. Okay, sorry for that. Okay, so it's probably kind of calculating, probably takes time. Yeah, the layout might not be that ever greatest, but yeah, it just probably doesn't fit into the width. It doesn't matter really. But it runs from the 2000s, which is fantastic. So calculating, and so this print is calculating, allocated. Okay, so it did manage to allocate. Current factor 3. And should print something like this. Kind of primes. Yes, I don't know, probably need to wait until this. I'm not sure, but yeah, I'm already, I'm so excited by the fact that actually this finally starts working at this 2000s starting memory address. Okay, by the time it's, I don't know, is it thinking, or so just to make sure that no errors, no opcode errors or something. Yeah. Probably thinking. Oh yes, it done. So we have 9592. So yeah, I'm not sure what's the right answer, but anyway, it just exists from the program, and yes, it just does everything perfectly well. So, oh my god, guys, do you imagine Stockfish on KIM-1? That would have been that would have been interesting. Well, something easier for us, but anyway, now we have 6K of RAM to work with, and yeah, this is getting really interesting. This is getting really fantastic. So yeah, I'll probably now spend a little bit more time on this hex dump thing and the disassembler. So let's search for RAM further on. Okay, so this is okay, guys. Yeah, probably I just stop here because this takes another hour. Anyway, we got this nice memory extension for memory expansion for our KIM-1, so we have like almost 60K more memory now. I just need to make sure that hex dump and disassemble are working properly so that you can display that data, those bytes in the expanded RAM as well. And hopefully starting from the next video, we'll already try to compile some chess engines for this. That's it from my side. Thanks for watching. Until next time, and take care.